Okay, looks like we're ready to start the KETIV Virtual Academy for today. Today we're going to be looking at product configuration in Tacton CPQ. So let's get started. So a quick look at the agenda. We're going to do a quick introduction as to who I am, the presenter, and for KETIV. And then we're going to look at what is CPQ, and then we're going to look at how to model a product in CPQ as well. So, a quick introduction. I am Joshua McBride. I'm a senior CPQ Solution Architect here at KETIV, and I have 20 years of engineering and automation experience. Recently, I've actually come from Blue Origin working on the Lunar Lander project. There, I was the engineering and data systems engineering and architecture lead. I came to KETIV because I love the people, love what KETIV's doing, and love working with so many different types of manufacturers, and ultimately working in the CPQ project or product that we're working on today. So a little bit about myself. I recently started flying powered paragliders and made some flights over the canyons in Farmington, New Mexico. That was really awesome. But I usually fly around Oklahoma where I live. So let's talk a minute about KETIV. Who are we? Well, ultimately, KETIV's goal is to revitalize American manufacturing for a better tomorrow. That's really our passion and what we want to achieve as a company. So how are we trying to do this? Well, as your partner, we seek to increase your efficiency and productivity from customer engagement through manufacturing and ultimately all the way back around to service, back around to the customer. So in order to do this, we need to offer something that we can provide and increase your efficiency in every aspect of the business, all the way through the process. And that process starts with CPQ at the beginning. So KETIV has partnered with Tacton to provide that particular aspect. This is a very important piece because all downstream processes are fed by the interaction with the customer. So if we can really get that first piece right, everything else will become more efficient as well. So let's talk about Tacton CPQ. Ultimately, what is CPQ? That stands for Configure, Price, Quote. Why does KETIV choose Tacton? KETIV is the only US provider of Tacton CPQ. Tacton uses patented AI developed at the Swedish Institute of Computer Science. Ultimately, this provides constraint-based configuration, which allows for complicated yet quick product solutions and only solutions that are possible to actually construct. It also provides product design optimization. This is things like if you want to optimize for the most efficient product versus the most affordable product, things like that. It also provides interactive visualization, and there's also augmented reality, in which you can see the product in real time, in real space, walk around it, step inside of it, view it as though it were actually there. And finally, what we're really going to be looking at today is how easy it is to implement and maintain. And we're going to do that through a demonstration in which I will actually be creating a product in Tacton CPQ with you today. So I'm going to give you a little bit of understanding about what we're about to do. So don't worry, I know this looks like a lot, but we'll break it down, and I think you'll find it's pretty straightforward. So here we have what are called domains, and domains are basically definitions for features. Features are utilized by modules. Modules have variants within them. These modules can then be assigned to different positions in an assembly, and then the assemblies have attributes which are also defined by domains. So let's break it down, and we'll look at this example of, say, a nut. So in the case of a nut, the nut would be our module. It's just a generalized term, nut, that could have multiple variants to it. So a nut is ultimately defined by three, at least in this example, three different things. In this case, it's going to be the pitch of the thread, the size, and the type. That is all defined by domains. In this case, the thread pitch is an integer, the size is a float, or basically something that has decimal places, and the type is going to be, in this instance, a hex or a blind nut. Then the variants are combinations of these features. So, for example, we can have a lot more than this, but just as an example, we can have a hex nut that is half inch, that is 20, and versus one that is 32 for its pitch thread. So if we look at an assembly, the assembly can utilize modules, and in this case, we're going to have a nut and a bolt. The nut and the bolt get assigned to different positions within that assembly. The reason we do this is maybe in a different instance, we could have multiple nuts to a single bolt. So we can have two positions utilizing the same module. So the assembly has a nut and a bolt, and then the assembly itself has attributes. In this case, it's going to be the size and the thread pitch. That is utilized in order to match up the features between these two in order to make sure that the bolt and the nut can actually go together. And then, of course, those are defined by domains. The same domains that maybe we used earlier in the instances of the bolt and the nut. Now that we're in the Tacton environment, I've already started a new ticket for this example. And we'll start by moving to the domains and defining those there. So there's already some existing, but in this case, I'm going to add enumerated. We're going to call this the nut domain. And in this domain, we're going to define the types of nuts. And just for this example, we're going to keep it short, but we're going to call it hex nut. And we will also have a blind nut option. So we also need, in order to define our nuts, we're going to need sizes. So I'm going to go ahead and create another domain for that, rather than just leaving it an open integer or an open float, because that would provide way more options than the options I actually have available. So I'm actually going to create another enumerated domain. We'll call this size. And we'll say half inch. We can do it this way. And we'll have a 1 inch. And just for the sake of time, we'll only do 3. We'll have a 1 and 1/2. Last thing we're going to need here is, at least for the nut, is to define the thread pitch. the nice thing is a lot of times when you're creating this, you already have data that you can pull this from and populate it with so that you don't have to type it all in. Usually it's pulled out of an ERP system or something like that. So we'll have a 20. Just for an example, we can do all this in Excel. We can export it, modify it in Excel, re-import it. The nice thing about that is you can grab a whole bunch of data from your ERP system or something like that and upload it, and it makes it a whole lot quicker. But since we only have a couple more to do, we will just type it in here. Okay, so for now, just for the sake of time, we're going to leave that there. Next, we're going to define our module. So this is where we're going to add the nut. So just to keep things straight, I like to add a little abbreviation here. Now we're going to add our features, which is size, and we're going to use our size domain, and then we'll create our next feature, which is going to be our pitch. Pick our pitch domain. We'll add that. And then lastly, we have our type, or nut type. We will pick the appropriate domain. And now that we have those features, we can start defining our model variants. So basically, within those model variants are the combinations of the features that we have. Now, I'm going to go ahead and export this to Excel so we can see what this looks like. So here we have the name and the description. This would usually be something like an ERP number. I'll make it an N-1 for nut. And we'll hop down here. We can see our enumerated domains, and we can see the different options. So we'll start with these, and I'll drop it in to our size feature. And then we've got 20 and a 32. So for our pitch, 20, we'll grab all this, copy it, paste it, and 32, paste that. And then we also need to have whether or not we're a hex or a blind. So we will add hex here, pull that all the way through, take all these, paste it, and we will make this blind. And now we have all our variants. These are all standard, so we're going to put a no here. And we're going to make all of them active so that they are all available. And then for our description, we'll make it pretty easy here. We will create our description, not 1/2 inch, 20 hex, We're gonna go to the next cell, hit Control E. That'll attempt to fill it out for you. It gets pretty close. Not quite. We'll correct it, and that'll fix it all for us. Now we have all our descriptions ready to go. We'll close, save it, and it will load it into Tacton for us. There we go. Okay, so now we're going to make another module. This is going to be our bolt module. We'll add that. And we're going to add a couple features here, which is going to be our size. I'll make sure I pick the correct domain. And we're going to have our pitch. And make sure we pick the correct domain. Add that. And we'll go ahead and define our variance. So you can see there's another way to do this if we don't use the Excel. So in this case, we'll call it B-1 for bolt. And this will be bolt. And with the size of 1/2 inch. And it will be a 20. Make it active. Add. Then I'm going to actually go ahead and we'll just do this first one. We'll select 1/2 inch. We can select the pitch. And now that is defined. And I'm going to hop over to Excel in order to finish this out a little bit quicker. So we'll grab our domains here. This out. And we got a 32. 32. Put that in each one of the cells. We'll say no, it is not non-standard, meaning it ultimately is standard. Make all these active. Write this down. And then this we should be able to hit Control E. And didn't quite catch that. So we'll fix it here. 20. And that helps straighten it out right there. And it gets the rest of them correct. So now we're done with that. Hit the X, save, and it will then load it in. Now we have all our bolt variants. At this point, we're ready to start our assembly. So we will add a new assembly here. We'll call it fastener. We add that. And we'll add a couple positions. This will be bolt position. And it's already set to be the bolt module. So we're good there. And we'll add that. And then we will add the nut position. We'll select the nut module and add that as well. Now we're going to add some attributes. We're going to add the size. And here, once I do this, size domain, I'm going to add that. I'll explain why we're doing this here in just a second. And then we're going to have the pitch. And select the pitch domain and add that. So by putting these in here, I can utilize these in order to equate the bolt position and the nut position features of size and pitch. So to do that, we'll click the feature name, and here where it says aggregation, we're going to set that to equal, save that, and then under aggregation, we'll click this and select our size features by clicking the plus here and the plus here. So what that's going to do is it's going to make the size feature equal between all of these, the different positions and the assembly. So we'll save that, and we'll do the same to our pitch. Set the aggregation to equal, and then select our two positions and save that. Okay, so at this point, we're actually ready to make the interface for the user to interact with. So we're going to go to Product Models. We're going to add a model here. We'll name it Fastener. And add that. And then we will add our top position. And oops, too many times there. It's all right. And our fastener assembly is selected. We will add that. Now we can go to the View Designer, and we will add a tab. We'll call it Selection, Add. Then in that tab, we're going to add a field. We'll give it a quick name. We'll just call it Size. And for our attribute, we will select the size attribute. Add that. We'll add another field. This is going to be our pitch. Call it thread pitch, at least in the description. And we'll select the pitch attribute, add that. And then we're actually going to add our type feature for the nut. So we'll call this nut type and nut type. And we will add that. Okay, so a quick run of this. Click the run. We get our results here, so we'll expand these so we can see all the results that we get. We'll change the size to 1 inch, and what we will see is our bolt position and our nut position both change and become 1 inch. You can select the 1.5 inch. Same thing occurs as well. We can change the pitch, and once again, it changes to match. And then maybe instead of a hex nut, we want a blind nut, and that changes there. Of course, we can see our variant changes as well in order to match so that we get the correct part number being selected, and which we're not going to show today, but that can ultimately feed into pulling a price based upon that part number, and that's where you ultimately get your price from. So you can see here very quickly how I can create a product model within here, within Tacton CPQ. And the nice thing is that also makes it very easy to change and maintain. So if there was, for instance, I wanted to have another nut, so maybe we wanted the possibility to double nut it in order to make sure that maybe vibrations, it doesn't back off or something like that, we'll just hop over to our assemblies, select the fastener assembly, and what we're going to do here is we're going to add an attribute. We're going to call it double nut we're going to make it a Boolean. We'll add that. And then we're going to modify the nut position. And instead of the quantity being static, we're going to make it configurable. We have a minimum of 1, but we could have 2. We'll change the max to 2, save that. Then we're going to go over to our constraints tab. We're going to add a constraint here. The nice thing here is it gives us the possibilities so that we can not only select it, it makes it faster and easier. But the other side is we cannot make a constraint that is not possible. So we're going to select the double nut. We're going to say that if and only if, that's what this means. This is an if. This is if and only if. So if and only if the double nut is set to yes, then the nut position is going to have a quantity equal to 2. That way, if it's set to no, it will drop it back to 1. We'll add that. And let's go back to our product model, select fastener, view designer, and we're going to add the double nut field. We're going to select the double nut attribute, and we'll just make it a checkbox. Add that, and let's give it a run. So we can click the checkbox, and we can come down here and we can see the quantity is now 2. We can uncheck it, and it is back to 1. So once again, very quick, easy. A lot of it, you can kind of figure it out as you go, experiment with it. But once again, it makes it very easy to trace back what somebody else has done, find what they've done, change it, and update it, maintain it as necessary, and expand your models. So very quick and easy to do. So with that, ends our demonstration. So we'll go ahead and take this moment to address any questions that haven't been answered as of yet. Okay, well, it looks like we don't have anything in our chat from what I'm seeing. So yeah, if there's nothing else, oh, well, I said that. Here's one. Let's see. What does the CAD application come in? So, or yeah, where does it come in? I'm sorry. Yeah, so the CAD application, or let me back up. The visualization does not use CAD. So, I want to be clear, there's no confusion there. All this information that comes out of Tacton CPQ can feed to a CAD application. And in fact, it can feed to Inventor, CATIA, SolidWorks, I believe NX as well, most any CAD application. And so what you can do is you could actually feed that information to the CAD system, produce your drawings for the shop if necessary. You can also have it run on basically a server so that it could produce the drawings. Those drawings could be automatically put into Tacton and provided as part of the quote as well. That would be the speed of that would basically be based upon the speed of the system that is running the CAD software. So that's a possibility as well. I'm assuming, okay, so will there be a demo in the future showing something on screen? I'm assuming that is in reference to the CAD system itself. We don't have that in the schedule, but that's probably something we could do. Okay, yeah, correct. That was the question. Yeah, that's certainly something we could add to this to the KVA at some point. So we can definitely make note of that. Ultimately, if you want to see that and go into detail, you have a lot of questions in that area, we could put together a demo specifically for you. So, feel free to contact us. And in fact, I will put my information here in the chat. I'll answer it to you and I'll put it out for everybody as well. So you can contact me directly. Yeah, we could do something specific for you guys so you can see, ask specific questions, and really dig into detail about that and how that works in detail, if that's something you're interested in. Okay, we'll give just a second for anybody else if there's any other questions. I'll put my email in here real quick before we move on, make sure that everybody gets that. So there's my email in the standard chat, and yeah, that should be it. So we will have some follow-ups. Our next one for Tacton itself, we're going to cover needs-based configuration. Basically, rather than having the customer or the user simply select parts, we can have the AI configure the object based upon things like weight, speed, pressure, stuff like that. And then we'll get into optimization. We can select and have the configurator select the best, whether that be optimizing the performance, optimizing on price, and so forth. And so we'll look at those. And then once again, we have the suggestion to look at the CAD piece. So maybe we'll get that in there after those as well. All right, well, if it doesn't seem to be any other questions, that is the end of our KVA, and appreciate everybody's time, and we'll talk to you later.